Welcome back. So if you look on the whiteboard, I have two equations up here. They have equal signs. Yes, they are linear. They're x to the first power. X to the first power. They have fractions in them. We see the fraction bar. So we can call these rational equations. But more specifically, because on the left side there is one fraction, and on the right side there is one fraction, this is called a proportion. Now you're going to say, how do I know there's one fraction on the left? Well, there's one fraction bar that contains all those terms. There's one fraction bar that contains all these terms. So if we know our equation is a proportion, a fraction equals a fraction, a quick way to solve this is to do cross products, which means to crisscross and multiply. The way I used to show this when I taught elementary school is I'd make the kids make loop-de-loops. So we're going to multiply across, and we're going to multiply. Now, that should make no sense, and that's what I want you to understand. There's no multiplication symbol up here. So this is a trick we use to solve to get rid of the fractions. It just happens it works all the time. That's why it's a great trick. But you can only use it when you have a proportion. So I want to multiply 5x plus 2 times 2, which means I have to use my distributive property. 5x times 2 is 10x. Positive 2 times 2 is positive 4. Then you put the equals, and then you multiply the next loop. 3 times x minus 1, again, we would have to distribute. 3 times x is 3x. 3 times negative 1 is negative 3. And what happens now is now you still have a linear equation, but now you have no fractions. So it makes it easier for you to move the terms, to get the like terms together. And that's what we're going to do. Here's our wall. Ms. Black's rule of thumb is you always get the variables to the left. So I'm going to move 3x by subtracting. 10x minus 3x is 7x plus 4 equals, these terms are additive inverses. We're adding the opposite, so it makes 0. It cancels out, and we have a negative 3. Now I'll move my numbers. I move add and subtract first, so I subtract 4. 7x, additive inverses cancel out because they make 0. These terms are both negative. We'll add them, we'll get negative 7. We're not done. We're going to divide by our coefficient 7. That leaves us x equals negative 1. And that is your solution. And you know because it was linear, it was x to the first power, we should have one solution. So cross multiplying is wonderful, but it only works on solving proportions. Now, just to show you, I could have solved this proportion using the least common denominator, that other method, and we still would get the right result. If you look here, what's the least common denominator of 3 and 2? Everybody? Good, it's 6. So I could take this equation, multiply it side by 6, take this equation this side, multiply that side by 6. Everybody's good? Now, we talked about this. This is 6 times, and we have divide by 3. It is easier always to do division first. So 3 goes into 6 twice, and that would leave me 2 times 5x plus 2 equals 2 divides into 6 3 times, and that would leave me a 3 times an x minus 1. So if you look, by using the LCD, we still got rid of the fractions. If we distribute now, everybody watch this, 10x plus 4 equals, we distribute 3x minus 3. So if you look, we're back to the same linear equation. So what I tell my students in class is, if you're dealing with an equation that has fractions in it, getting the LCD will always work. It will always wipe out the fractions. However, if you're guaranteed your equation is a proportion, another option to get rid of the fractions is do the cross product, cross multiplying. Okay, see you in the next module.